Hi, welcome. Today we are going to take some statistics questions. That's Maths 153 MCQs. We see how to solve them, how to use a calculator and a lot. So kindly take your book, your pen and your calculator so that you follow me as I do it, okay? In order to verify everything I'll be doing. Now, if you are new to this channel, kindly do well to click on the subscription button, like subscribe to my YouTube channel so that whenever I post something you can watch, you can see it very early. Okay, so let's proceed. Question number 1. Question 1 says the set of all possible outcomes of a random experiment is known as A, permutation, B, combination, C, probability, and D, sample space. Whenever you see this kind of question, don't waste time and before you provide your answer. The answer is D, okay, sample space. Okay, so let's proceed. Question 2 says, in how many ways can the letters of the word Mississippi be arranged? To do this, what you're going to do is that you count the number of letters in the word. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. So you are going to say 11 factorial. 11 factorial. This is how we write factorial. You write it like exclamation sign, something like that. So 11 factorial divided by, now how many m's do we have here? We have 1 m. Okay, we have 1 m. So we say 1 factorial. But most people ignore it whenever you have one letter. They don't write it because like 1 factorial is still 1. So what do you need it for? Like, so we don't write it mostly. But you should know there can be 1 factorial there. Then times. So since we forgot it, I will forget the multiplication as well. So the next thing is, how many i's do we have? We have 1, 2, 3, 4. We have 4 i's. So we say 4 factorial. We say 4 factorial times, that's multiplied by, how many s do we have here? We have 1, 2, 3, 4. We have 4 s. So you also say times 4 factorial again. 4 factorial multiply by, that's times. Let's see how many p's we have here. We have 2 p's. So we say 2 factorial. 2 factorial. Now to solve this, you take your calculator. So let me show you how to do that. Now this is where the factorial is. This part of your calculator. This, check beside the on, there is mode there. Under the mode, a key right under the mode is that's where the factorial is. But before you click it, you can fix the numbers. You bring the division sign, then you type 11. So to get a factorial, you press shift before you press the key. If you don't press shift before the key, you won't get a factorial. Then you go to the denominator and fix the values there as well. Then you press equal to sign. When you do that, you get the right answer. So the correct answer for question 2 is question 3, right? Question 2, right, is C. That's 35,450. As if you fix the values well, you get the right answer. Okay, so let's go to question 3. Question 3 says a coin is tossed and a die is rolled. Find the probability of getting a head and then rolling a 6. Now to solve this kind of question, ask yourself, how many possible outcomes do you have in tossing a coin? How many possible outcomes do you have in tossing a coin? We have 2 possible outcomes, isn't it? And how many possible outcomes do you have in rolling a die? We have 6 possible outcomes, isn't it? When you toss a coin, it's either you get a head or a tail, so you have 2 outcomes. When you roll a die, it's either you get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possible outcomes, isn't it? Now, to solve this question, look at the word here. Find the probability of getting a head and then rolling a 6. In probability, when we say and, it's talking about the multiplication, okay? When we say or, it's talking about the addition. So, to solve this, what's the probability of getting a head? There is only one head in a coin. So the probability of getting a head should be what? 1 divided by what? The total possible outcomes, which is what? 2. Isn't it? Yeah. Then, it says and means what? Multiplication, so times. What's the probability of getting a 6? There is only one 6 in a what? In a die, isn't it? A die, one die. There is only one 6 in a die. So since there is only one 6, we say 1 divided by what? How many possible outcomes are in a die? 6, right? So 1 divided by 6. 1 divided by 6. So this will give us, when you are multiplying two fractions, you multiply both the numerator and multiply the denominator as well. So 1 times 1 is what? 1, isn't it? Divided by 2 times 6 is what? Is 12. 2 times 6 is 12. So the correct answer for question 3 is 1 divided by 12, sorry. So the answer is C. The answer is C. Okay. So let's proceed to question 4. Question 4 says, which of the following is not a quantitative variable? Which of the following is not a quantitative variable? So let's look at which of them is not a quantitative variable. So to answer this, let's see. Political affiliation is a qualitative variable. Okay, when something is non-numeral, when it's not in numbers, okay, when a variable is not a number, it is a qualitative variable. So political affiliation is either you are NPP, NDC, QQQ, CPP, MMM, or wherever. It's qualitative variable. Okay, qualitative. Okay, so let me say L. Let me write it as L. Or yeah, qualitative variable. Okay. Then religious preference. It's either you are a Muslim, a Christian, Africa traditionalist, and wherever. Your religious preference is also qualitative variable. So it's the same as A. Okay. So it's the same as the A. It falls in the same distance with the A. Then let's also say height. Height is quantitative. So height is quantitative. Okay, height is quantitative. So be very careful with that. Height is different. Height is quantitative. Then gender. Gender is also qualitative because it's either you are a male or a female. It's not in numbers. So gender also falls in the same category with the political affiliation and the religious preference. But when we look at the question says which of the following is not a quantitative variable? It's not. Please be very careful. It's not a quantitative variable, meaning that the question is expecting all of them to be quantitative except one. But here lies the case that the possible answer is not in line with the question. Oh, so there is no answer in this. Maybe there was a mistake in the question. Okay, you see such a case like, yeah, if I were you, I would just raise up my hand, call the invigilator and let him know that this is the problem I'm having with question 4. Okay, they can ask you to change certain things inside or something. But if I had said the question, I would have written it. That's why every time when you want to write an exam, read the info at the top of your question paper. Always read. Okay, personally, if I'm a lecturer or like a teacher, I would have written over there that if you think the answer is not in, shade E. If you think the answer is not E, it's not there, sorry, shade E. That's what I'll say. Okay. So always read your questions, everything very well. So let's see. If the question had been, which of the following is a quantitative variable, the answer would have been C. Or if the question had said, which of the following is not a qualitative, instead of quantitative, then they rewrite it as qualitative. Which of the following is not a qualitative variable? It's only C that is not a qualitative variable, so the answer is still C. So be very careful with like this kind of situations when you are writing exam. And that's why it's very important to read the questions very well before you pick an answer. Okay, so let's proceed to question 5. So it looks like there's no answer for question 4. Yeah, I deliberately do it like that so that because I've experienced such cases before. Okay, so question 5. In how many ways can the letters of the word statistics be arranged? So we are going to solve it like the question 2 we solved. So we count the number of letters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you say 10 factorial, 10 factorial divided by how many s do we have? We have 1, 2, 3. So 3 factorial times how many t's do we have? We have 1, 2, 3. So we have 3 t's as well. So we say another 3 factorial, another 3 factorial times how many a's do we have? We have only 1 a, so there's no need writing 1 factorial. Let's see again, something else. I. Okay, so how many i's do we have? We have 1, 2. So we have 2 i's. Okay, we have 2 i's. So we say times 2 factorial. So you go to your calculator, then you bring the division sign first. The division sign, okay, you bring the division sign first. It's here, it's under the calc. Look at where the shift is. Right under the shift, you see calc, and under the calc too, you see the division. So you click on it, then you input 10 factorial, and I show you where the factorial is, shift and the key under the mode. Okay, then you go to the denominator and fix the values there to 3 factorial times 3 factorial times 2 factorial. Then you press the equal to sign, the equal to key, sorry. So when you click on the equal to key, I believe you get the answer to be A, 50,400. So the correct answer for question 5 is A. So let's proceed to question 6. Question 6 says, in how many ways can the letters of the word corona be arranged if the 2 O's are separated? If the 2 O's are separated. Please, there is a condition here. The question 6 is quite different from question 5. Kindly take a look at this and pay attention to this. Okay. To solve the question 6, what you're going to do is to find the general number of ways in which corona can be arranged. So let's first find the general number of ways, just like how we did the question 5, the number of ways in which corona can be arranged. So that would be 1, 2, 3, 4, 5, 6. So that would be 6 factorial. 6 factorial. Sorry for my bad handwriting. Okay. 6 factorial divided by how many O's do we have? We have only 1 C, right? So you don't need writing. How many O's do we have? We have two O's. So we say 2 factorial. 2 factorial. How many R's do you have? We have 1. How many N's do you have? We have 1. How many A do you have? We have 1. So there's no need writing there. So 6 factorial divided by 2 factorial. You can take your calculator and do that. 6 factorial divided by 2 factorial should give you 6 times 5 times 4 times 3. Stop there. So when you do it well, I think you get 360, right? So the answer is 360 for this, for the general number of ways in which it can be arranged. So 360 ways. After that, you also find the number of ways in which corona can be arranged if the 2 O's are together. If you pick the 2 O's and consider them as 1, and you recount 1, the 2 O's are now 1, so we say 2, 3, 4, 5. So you only have 5 numbers, right? So you have 5 letters, sorry. So you say 5 factorial. 5 factorial. Now they are all now 1, 1, 1. C is 1, R is 1, N is 1, A is 1. O is now 1 because you've taken them together. So there's no need dividing it by any 1 factorial anymore. So 5 factorial gives you what? That's 5. 5 factorial means 5 times 4 times 3 times 2 times 1. That's the meaning. So 5 times 4 is what? That's 20, right? 20 times 3, that's 60 times 2, 120. Times 1, that's also 120. So 5 factorial is what? If the 2 O's must be together, you get 120 ways. So to solve the question and like how many ways can it be arranged if they are separated? what you do is to take the 360 minus the 120. So 360 minus 120 gives you what? 240 ways. So the correct answer for question 6 is C. So let's proceed. Question 7 says, the number of occurrences of a data value is called, without wasting much time, it's number of occurrences, the frequency, okay? Is a frequency. Number of occurrences is a frequency. Okay. Now, question A says, which of the following is said to be the lowest or the most primitive level of measurement? Without wasting much time, you should know is the nominal. Okay, when you go and read about the nominal level of measurement, you see such, they will tell you that it's the oldest. Okay, so the correct answer for question 8 is C. So please don't forget, whenever you see this question, the answer is C. So let's proceed to question 9. Question 9 says, which of the following is a discrete variable? Which of the following is a discrete variable? When we talk about discrete variable, it's talking about something that deals with now countable, like it's countable. Okay, let me remind you of something. Remember that we have our qualitative variables and quantitative variables, isn't it? And under quantitative variable, we have, the quantitative variable is divided into two. We have discrete variables and continuous. And we say the qualitative are not in numbers. Okay. And we also say the quantitative are in numbers. And the quantitative is further divided into two, discrete and continuous. The discrete, you can easily count it. Whereas the continuous, you can't just count it, but you can, most way of getting it is by measuring it. So if we check the possible answers, A says weight of students enrolled in a statistics class. Can you count their weight? No. So the answer is not A. B says the number of students enrolled in a statistics class. The number of students, the number. You can count the number of students. Okay, you can count the number of students. So that makes the answer for question 9B is a discrete variable. But check all the possible answers. Well, weight is continuous. Okay, this is continuous. Brand of PC is not in numbers, so this is actually qualitative variable. Then height is quantitative, but it falls under the continuous. So the correct answer for question 9 and pi is B. Okay, so let's proceed. Question 10 says, colors of student t-shirts and KNUST is. Colors of student t-shirts and KNUST is the colors. The color of your t-shirt is not in numbers. Okay, it's either your t-shirt is blue, black, green, yellow, white, or black. But the color of your t-shirt is not in numbers. Okay, so that makes it a qualitative variable. Okay, it's not in numbers. So it's qualitative variable. So the correct answer for question 10 is C. Discrete variable and continuous variable are in numbers, and they are both under quantitative variable. So the correct answer for question 10 is C. Okay, so let's proceed to question 11. Question 11 says, a card is drawn from a well-shuffled pack of playing cards. Find a probability that it is either a diamond or a king. To be able to solve this question properly, okay, let's look at something. The question says we should find a diamond, or, please take note of this, or a diamond or a king. A diamond or a king. Now, before that, remember, when you were studying probability, you were told that under the addition law, okay, addition rule, or is addition, right? You were told that, or you were taught that probability of A or B, that's union B, or is union A or B, is equal to probability of A occurring plus probability of B occurring, minus, that's the general rule, probability of A intersection B, A intersection B, that's A and B, A intersection B. And also, if the two events A and B are mutually exclusive, okay, if the two events A and B are mutually exclusive, meaning when there is no intersection, then you are not going to use the first formula I quoted, you are going to use the second one. Probability of A union B, A or B should be equal to probability of event A occurring plus probability of event B occurring. So which of these two formulas are we going to use for this question? So to be able to know that, question A, for the first one I quoted, when there is an intersection, that's when you use it. But when there is no intersection, that's they are mutually exclusive events, we are going to use the second one. So let's see which of them are we going to use. So let me show you an image of a card. Now look at this card. This is a diamond, right? This is a diamond. So let's count the number of diamonds here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 diamonds, isn't it? Yes. We have 13 diamonds. And how many kings do we have here? We have 4 kings, isn't it? So we have 1, 2, 3, 4. At the left, at the right, we have the king there. We have 4 kings there, written in K. Okay. Now, when you look at the diamond and the king, you realize that there's an intersection of 1. There is one particular card which is a diamond at the same time a king. So that's an intersection. And it's only 1. So how many diamonds do we have? We have 13 diamonds, isn't it? How many kings do we have? We have 4 kings. And how many intersections do we have? We have only 1 intersection, isn't it? So to solve this question, we are going to use the first formula, okay? So probability of diamond union or king, diamond or king, K, is equal to, what's the probability of getting a diamond? How many diamonds do we have there? We have 13. So we say 13 divided by, the total number of cards is 52, okay? So 13 divided by 52 plus, how many kings do we have? We have 4 kings, isn't it? So we say 4 divided by 52 again. Total number of cards is 52, isn't it? Minus the intersection. What's the intersection? The intersection is 1, right? So 1 over 52. Over 52. Okay, so this gives you, now in addition and subtraction of fractions, okay, when you're adding and subtracting fractions, not multiplication and division, please, without using calculator, when you're adding and subtracting fractions that have the same denominator, okay, just do like this. Just take the denominator once, 52. Just take the denominator once, okay, then you operate the numerators. That's 13 plus 4, 13 plus 4 minus 1. So 13 plus 4 is 17, minus 1 is 16. So the answer is 16 over 52. You can use your calculator, please. Okay, you can use your calculator. I don't have a calculator here, that's why I'm doing that. So the correct answer for this is 16 divided by 52. But when you check the possible answers, there's nothing like that. We don't have 16 over 52. We only have 17 over 52. But don't choose it. Check if you can simplify 16 over 52 further. Yes, we can. 4 goes into 16 how many times? 4 times, isn't it? And goes into 52 how many times? 13 times. Check it out. 13 times. So the answer for this is 4 over 13. So the correct answer for question 11 is B. Okay, yeah. So let's proceed to question 12. Question 12 says, when a straight line segments are connected through the midpoint at the top of a rectangle of a histogram with two ends tied down to the horizontal axis, the resulting graph is called. So what's the resulting graph? Oh, the resulting graph is called the frequency polygon. So the correct answer for question 12 is C. Okay, straight line segments are connected through the midpoints. Okay, whenever straight line segments are connected through the midpoint, it forms a frequency polygon. So let's proceed to question 13. Question 13 says, a questionnaire concerning satisfaction with financial aid office on campus was mailed to 50 students on a university campus. The 50 students in this survey are an example of A. So question 13, what do you think the answer is? It should be a sample. Okay. The total number of students is on campus. Okay. The interest is campus. And we know that the total number of students on a university campus. Okay. The total number of students on a university campus is not 50. Okay. So those that you mailed it to is a sample. That's 50 students. So the answer is D. Okay. So yeah. So let's go on. Let's proceed to question 14. Question 14 says, let A and B be the two possible outcomes of an experiment, and suppose probability of A is equal to 0.4, probability of A union B is equal to 0.7, and probability of B is equal to P. For what choice of P, it's like they want you to find P. For what choice of P are A and B mutually exclusive? If you remember, when I was giving you some two formulas, I told you that when events are mutually exclusive, you're only going to use the formula A union B, A union B is equal to probability of A plus probability of B without subtracting the intersection, since they are mutually exclusive. That's the formula you are going to use. So plus probability of B. Probability of B. Okay. Now, let's substitute so that we get our answer. Probability of A is what? Is 0.4. Probability of A union B is 0.7. So A union B is 0.7. So let's substitute this in place of 0.7. 0.7 is equal to probability of A is what? 0.4. 0.4. When you actually understand, you can just look at the question and know the answer straightforward. You should just know that what will you add to probability of A to get 0.7? What will you add to 0.4 to get 0.7? That's what you ask yourself. Okay, so plus P. So when you group like them, when 0.4 comes here, it becomes 0.7 minus 0.4. That gives you 0.3. So P is equal to 0.3. So the correct answer for question 14 is C, 0.3. You just ask yourself, since probability of A plus probability of B will give me probability of A union B, then I know probability of A and I know probability of A union B. So what should I add to 0.4 to get 0.7? That's 0.3. So the answer is C. Okay, so quickly let's proceed to question 15. Question 15 says, given the data 25, 33, 4, 37, 19, 15, 20, find the interquartile range. To find the interquartile range, what you are going to do is to rearrange the numbers. So let's rearrange them. We have 4, we have 15. When we rearrange them, we have 4, 15, 19, comma 19. Then we have what else? We have 20. What else? We have 25. Then the next one is 33. 33. Then the next is 37. That's the last, right? 37. Now to find interquartile range, okay, you need to find the first quartile and the third quartile, and you find the difference between them. So let's see how to find first quartile and third quartile. To find first quartile, okay, to find first quartile, that's Q1. First quartile is equal to 1 over 4 first quartile meaning 1 over 4, okay, first quartile, 4. 1 over 4 times, so you count the number of letters and number of numbers, 1, 2, 3, number of values, okay, in the data, 1, 2, 3, 4, 5, 6, 7. There are 7, so you have to add 1 to it. So 1 over 4 multiplying by 7 plus 1. So 1 over 4 multiplies 7 plus 1. 7 plus 1 gives you what? 8. You can press it on your calculator. Then 1 over 4 times 8 will give you what? 2. Meaning the second position. 2. Okay, you say second. Second position. Okay. So what this means is that to get a first quartile, you count 1, 2. So this is the second quartile. 15 is the second quartile. Is the first quartile, sorry. So you find the second position to get a first quartile as 15. So to get a third quartile as well, that's Q3. Third quartile is equal to 3 over 4 multiplying the number of values in the data, that's 7 plus 1. You add 1 to the number of values, so plus 1. So 7 plus 1 gives you 8. 8 times 3 is what? 24. And 24 divided by 4 is 6. So that's the sixth position. Okay, it means sixth position. So to get a sixth position, you count 1, 2, 3, 4, 5, 6. So 33 is at the sixth position. Okay. So to get the interquartile range, the interquartile range is going to be the what? The third quartile minus the what? The first quartile. So that's 33 minus what? Minus 15. So 33 minus 15 gives you what? 18, isn't it? So the correct answer for question 15 is C, 18. So let's proceed to the next question. The question says, use the following information to answer question 16 to 22. So to do that, check the class and the frequency. I hope you've seen them well. Now question 16 is asking, the class mark for the class 21 to 30 is, this is the class they are talking about. So what is the class mark for this class? To know the class mark, you are going to find the midpoint, okay? You find a class midpoint. And to find a class midpoint, it means the lower class interval minus the upper class interval. That's 21 plus 30 divided by 2. You divide it by 2. Plus 30 divided by 2. So 21 plus 30 gives you 51 divided by 2. That's what? 25.5. So the correct answer for question 16 is B. Then question 17 says, the relative frequency for a class 11 to 20 is this class. To know the relative frequency, you need to find the total frequency. So to get a total frequency, 2 plus 4 is what? 6. Plus 1 is what? 7. Plus 7, 14. Plus 6, 20. So the total frequency is what? Is 20. Keep that. The total frequency is what? That sigma f is 20. Then, to know the relative frequency, you are going to take the frequency of that class specifically. That specific class. You take its frequency, which is what? 4. and divide it by the total frequency, which is what? 20. So 4 divided by 20 gives you what? That's 1 over 5, right? Yeah, 1 over 5. So 1 over 5 is the same as in decimal. When you take your calculator and put 1 over 5 on calculator, you should get 0.2, right? So the correct answer for question 17 is A. Okay, so let's proceed to question 18. Question 18 says the lower class boundary for the class 31 to 40 is. Now, to know the lower class boundary, what you're going to do is, we are finding the lower class boundary for this class. So let's mark it down, this class. To know the lower class boundary, come here, take this number, the lower class of the second class. You can do it for any of them, but I just want to follow some. Listen, take the lower class of the second row, okay, then the upper class of this place. What's the difference between them? The difference means you subtract them. That's 11 minus 10. This minus this. It gives you what? 1. The result divided by 2, you get 0.5. To get the class boundaries, meaning that 0.5, you are going to be robbing Peter to pay Paul. What I mean by this is that you rob one of 0.5, you rob this Peter of 0.5 and pay Paul the 0.5. You subtract 0.5 from the lower class and add it to the upper class. That's what I mean by that. So, to get a lower class boundary of this, since we've gotten 0.5, let's subtract 0.5 from 31. We get 30.5, isn't it? When we add it to 40, it gives you 40.5, isn't it? So the lower class boundary will be 30.5 and the upper class boundary for this place will be what? 40.5. So the correct answer for question 13 is 30.5, which is B. So let's proceed to question 19. Question 19 says the upper class boundary for the class 21 to 30. We already have 0.5. Okay, so we are finding for 21 to 30, the upper class. The upper class should be, when we subtract 0.5 from here, add it to here, it will be 30.5, isn't it? So, and that's the upper class. So the answer for this one too is 30.5. Okay, so the answer is 30.5. So the correct answer for question 19 is C, 30.5. Then let's look at question 20. The question 20 says the cumulative frequency for the class 21 to 30 is. Now, to find cumulative frequency, what it means is that, now if you want to find a cumulative frequency of this class, okay, let me create a new table. Cumulative frequency. Okay, if you had wanted to find a cumulative frequency of this class, it will remain 2. Okay, if you want to find a cumulative frequency of this second class, you add the previous class frequency to it. So 2 plus 4 gives you what? 6. Okay, if you want to find a cumulative frequency of this class, this third class, you add 2 plus 4 plus 1. It gives you what? 7. If you want to find a cumulative frequency of this fourth class, you are going to add from the beginning 2 plus 4 plus 1 plus 7. That gives you what? 14, right? If you want to find the cumulative frequency of the last class, you add from the beginning to that last. So 2 plus 4 plus 1 plus 7 plus 6 gives you what? 20. Make sure the last cumulative frequency is the same as your total frequency. So, but the question is asking us for the cumulative frequency of the class 21 to 30. So the answer is 7. Okay, the answer is 7. So the answer is what? 7. So the answer is A, 7. Okay, A. Now the next question says the cumulative relative. Look at this. It didn't say cumulative frequency. It said cumulative. That's one thing. Relative frequency. It didn't say relative frequency, and it didn't also say cumulative frequency. They said cumulative relative frequency. Okay, for the class 31 to 40. So to do that, let's go to the class 31 to 40. This is a class for 31 to 40, right? This class. This where I've marked here. Now, to find a cumulative relative frequency, just like how we did if we were like how I taught you to find a relative frequency, to take the frequency of that class divided by the total frequency. To find a cumulative frequency, so you have to take the cumulative frequency of that particular class divided by the total frequency. What's the cumulative frequency of this class? The cumulative frequency of this class is what? Is 14, right? 14. So you take it 14 divided by the total frequency, which is 20. Let's take 14 divided by 20 quickly. 14 divided by 20. 14 divided by 20. It gives us what? It gives us 0.7, right? So the correct answer for question 21 is B. Okay. So let's proceed to the next question. The next question says, probability that a man will be alive 25 years hence is 0.3, and the probability that his wife will be alive hence is 0.4. Find a probability that 25 years hence only the man will be alive. This means that they say only the man will be alive. Okay, only the man will be alive. Now, what's the probability that the man will be alive? Let me ask you, what's the probability that the man will be alive according to the question? Is what? 0.3, right? 0.3. Isn't it? Now, what would be the probability that the man will not be alive? If the probability that the man will be alive is 0.3, then the probability that the man, you put this sign on it, the probability that the man will not be alive should be 1 minus the probability that he will be alive. Okay, that's 1 minus 0.3. And 1 minus 0.3 gives you a 0.7. 0.7. 0.7. Let's also see, what's the probability that the woman will be alive? The probability that the woman will be alive is 0.4, isn't it? 0.4. So if the probability that she will be alive is 0.4, what is the probability that she will not be alive? What's the probability that she will not be alive? It should be 1 minus what? 0.4, which is 0.6, isn't it? 0.6. We are just writing this down so that we can know how to solve a question. Now look at the question. The question says, find the probability that 25 years hence only the man will be alive. If we say only the man will be alive, this means that only the man will be alive. I'm trying to write the meaning. The man will be alive and that's multiplication. And when they say only the man is alive, it means that the man is alive and the woman is not alive. That's the meaning. So the man will be alive and the woman will not be alive. The man will be alive and means multiplication. The woman will not be alive. That's the meaning. Only the man will be alive. Okay, that's the meaning. So to solve this, what's the probability that the man will be alive? Is 0.3, isn't it? So 0.3 times, that's end. What's the probability that the woman will not be alive, which was the 0.6? So 0.6. So 0.3 times 0.6 gives you what? 0.18. So the correct answer for question 22 is B. Okay, so let's proceed to question 23. Interesting, right? Yeah. Question 23 says, a box of 9 golf gloves contains 2 left-handed and 7 right-handed gloves. Okay. If 3 gloves are selected without replacement, what is the probability that all of them are left-handed? What's the probability that all of them are left-handed? Now let's see. They say a box contains 9 gloves. Okay, 9 gloves. 9, that's the total number, right? 9. 2 are left-handed, 7 right-handed, isn't it? Now, if 3 gloves are selected without replacement, that's without replacement, what is the probability that all of them are left-handed? To do this, if they say without replacement, isn't it? What's the probability of selecting the first one? The first left hand, because the question says we should find for left-handed. What's the probability of selecting the first left hand? It should be what? 2. There are 2 left-handed there. 2 over what? Total, which is 9. Now, without replacement, you've not replaced it, so you are left with only 1 left hand over there. So the probability of selecting the second left hand is what? 1 over 8, and you are left with 8 balls, isn't it? Times, what's the probability of selecting the third left hand? You only have 2 left-handed balls there, gloves there, 2. You only have 2 of them, and you've selected your first, selected second. On the third count, you have no choice anymore, so your choice is 0. 0 divided by 7. Please look at this. They said you have 2 left-handed gloves. The gloves, 2 of them are left-handed and 7 of them are right-handed. Now, they said if you select 3 of them without replacement, what is the probability that all of the 3 are left-handed? And you and I know that there are 2 left-handed there. So when you select the first left hand, the probability of getting it is 2 over 9, 2 over the total, times, but they said without replacement, you didn't replace it after selecting it. So since you didn't replace it, you are left with 8 gloves over there, and also you are only left with 1 left hand choice to select. So the probability of getting the second left hand will be 1 over 8. And when you've selected the left hand, on the third choice, you have no choice anymore. So having no choice means 0. So 0 divided by 7. Now, 2 over 9 times 1 over 8 times 0 over 7 will definitely give you 0. When you are multiplying any number by 0, you definitely get 0. So the answer for question 23 is B. The answer is 0. 0 over 7 is 0. 0 times everything is 0. Okay. So let's proceed to question 24. 24 says, the cumulative relative frequency for a given class is defined to be A, the proportion of values preceding the given class, B, the proportion of values up to and including the given class. So the answer for this is B. Then C, the proportion of values for the given class, and D, the proportion of values below the given class is B. If you remember how I calculated the cumulative relative frequency, or cumulative frequency in pool, you add from the beginning to the given class. Okay. Then question 25 says, rating of 8 local players, poor, fair, good, excellent is which level of measurement? A, ratio level, B, interval, C, ordinal, and D, nominal. Anything that deals with ranking of something, when you are ranking, the answer is C, ordinal level of measurement. Whenever you are ranking poor, fair, good, excellent, when the thing deals with ranking, you are ranking things, okay, it is ordinal level of measurement. So don't forget that the correct answer for question 25 is C. Okay, it deals with ranking. Okay, we all know that excellent is ahead of good, and good is better than fair, and fair too is better than poor, isn't it? So that's ordinal level of measurement. So let's proceed to question 26. Question 26 says, Nanama read 4 courses last semester. For the credit hours, Math 153 is 3 credits. English 158 is 2 credits. Econ 121 is 4 credits, and ACC 154 is 3 credits. The exam was marked over 100, and she had 63 in math, 81 in English, 68 in Econ, and 75 in accounting. Calculate a weighted average for the semester. Now, to calculate a weighted average, are you following? This is how they calculate your CWA as well. To calculate your weighted average. So, average, another name for average is mean. Okay, so weighted average. Now, the weighted average should be the mark you get times the credit hours. Okay, the sum of all the marks times the credit hours divided by sum of the credit hours. What I mean by that is, what's your mark for Math 153? Your mark for Math 153 is 63, right? So you say 63 times, what's the credit hour for Math 153? The credit hour is 3, right? So times 3. Then you say plus. What do you get in English? You got 81 in English. So you say 81 times, what's the credit hour for English? The credit hour for English is 2 credits. Okay, so times 2 plus, what do you get in economics? That's 68. So you say 68 times, what's the credit hour for econ? That's 4 credit hours. 4 plus, then the last one, which is ACC, you got 75, right? Nanama had 75, so 75 times, what's the credit hour for that? The credit hour is 3, right? So you divide the whole thing by the sum of all the credit hours. So what are the credit hours? So we have 3 plus 2 plus 4 plus 3, right? So when you solve the top, I think you should get 848. If I've made a mistake, you can correct it. Okay, just follow the procedure. 848, I think so. 848. Without wasting time. Divided by, when we add this, 3 plus 2 is 5, plus this 9, plus this 12. So 848 divided by 12. 848 divided by 12 gives you 70.67. So the correct answer for this is A. Okay, so let's proceed to question 27. Now, if a class in a frequency distribution for a sample of 50 has a frequency of 5, and the cumulative relative frequency for this class is, look at something. It said if a class in a frequency distribution for a sample of 50 has a frequency of 5, the cumulative relative frequency for this class is, if a class in a frequency distribution for a sample of 50 has a frequency of 5, the cumulative relative frequency of this class should be what? 5/50. Okay, 5/50. That's A. So let's proceed to question 28. Question 28 says, if the first 5 classes of a frequency distribution have a cumulative frequency of 50 from a sample of 58, okay, the sixth and the last class must have a frequency count of, you have 7 classes, and from the first class to the 5th class, the total is 58. So if the entire total, the general total is 58, sorry, from 1st to 5th is 50, right? If the general total is 58, then the last 2 classes should be 8. That's 58 minus 50. Okay, so the answer for this is D. Okay, so let's proceed to the next question. Answer question 29 and 30 with the information below. A recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown below. So this is the result. Now, I think this is a conditional probability question. Conditional probability. So question 29 is asking that find a probability that the respondent answered yes. Find a probability that the respondent answered yes, given that the respondent was a female. To answer this question, this is how we do it. The probability that the respondent to answer yes, let's say yes is Y. Okay, given that, we use this sign. given that it's a female, okay, should be equal to probability of yes intersection female, yes intersection female, that's the formula, divided by probability that the person will be a female. It should be divided by the condition. It should be divided by the probability of the condition. What I mean by the condition is that this place, given that the respondent was a female, the female is a condition. Okay, so it should be divided by the probability of the condition. Okay, so when we substitute, what's the probability of yes intersection female? To get that, this is a yes, this is a female. When you trace them to get their intersection, yes intersection female is 8. Yes intersection female is what? Is 8 over what? 100. 8 divided by 100. The probability is 8 divided by 100. So 8 over 100 divided by 100. Divided by, what's the probability that the person will be a female? Total number of female is what? Total female. Total number of female is 50. So 50 over 100. 50, probability of female is 50 over 100. The total number of the general is 100. So 50 over 100. Okay. 8 divided by 100 or divided by 50 over 100 can give you 8 over 50. Please use your calculator. It can give you 8 over 50. And I think, can you simplify this further? Yes. 2 can go into 8 how many times? 4 times. And go into 50 how many times? 25 times. So the answer is 4 over 25. So the correct answer for this is A, 4 divided by 25. Okay. So without wasting much time, let's proceed. Question 30 says, find the probability that the respondent was a male, given that the respondent answered no. Find the probability that the respondent was a male, given that the respondent answered no. So he said we should find the probability that the respondent was a male. So M, given that, this is how we write it, given that the respondent said no, that's N. I didn't write this well. It's a diagonal something I wanted to do. Okay. Should be equal to probability of M intersection N, just like how we did male intersection no. Okay. Just like how we did the first one, male intersection no, divided by the probability of the condition. The condition here is what? Given that the respondent answered no. So the condition here is no. Okay, so divided by the probability of no. That's how to remember the formula. Okay, so let's check male intersection no. Male intersection no is 18. So the probability of male intersection no is 18 over 100, isn't it? There was a total number of no's. Okay, the total number of no is what? Is 60. So the probability of a no is also 60 over 100, isn't it? So the answer is going to be 18 over 100 divided by 60 over 100. So 18 over 100 divided by 60 over 100. So 18 over 100 divided by 60 over 100 should give you what? It should give you 18 over 60. And when you simplify it further, 18 over 60. When you simplify further, can we simplify it? Yes, we can. When we simplify it further, we should get, I think, 3 over 10. 3 over 10. Yes, 6 goes into 18 3 times and goes into 60 10 times. So the answer is B. The answer is B. Okay. At times, since they all have the same denominator, you can just take the intersection, that's 8, and just take it divided by number of no's, which is 50. straightforward without saying 8 over 100 divided by 50 over 100. Don't worry, just do it like this. So let's proceed. Question 31 says, given mean equals 15, median is also 15, and standard deviation is 2.8. Find the coefficient of skewness. Please don't waste time to solve this question whenever you see this kind of question. Whenever you have a skewness question where the mean is equal to the median, the coefficient of skewness will definitely be 0. Because the formula for coefficient of skewness is 3 into bracket mean, let's say mean minus median divided by standard deviation, or that's the formula for coefficient of skewness. So if the mean is 15, 15 minus 15 is 0. 0 times 3 is 0, and 0 divided by anything is 0. So the answer is definitely going to be 0. So whenever you have a coefficient of skewness question where the mean is equal to the median, please, the coefficient of skewness will be 0. Meaning it's neither skewed to the right nor skewed to the left. That's the meaning. It means it's symmetric. That's the meaning. When you get a coefficient of skewness to be 0, it means that the curve is symmetric. It is not right skewed and it is not left skewed as well. Okay. So let's look at question 32. Question 32 says, given 43, 61, 75, 91, 101, 104, the 25th percentile, 50th percentile, and 75th percentile are, to get a percentile, okay, to find a 25th percentile, that's P25. 25th percentile should be equal to 25 over 100. 25th percentile, okay, meaning 25 over 100. 25 over 100 times, how many values do you have here? 1, 2, 3, 4, 5, 6. We have 6 values, isn't it? So since we have 6 values, we are going to take the number of values and add 1 to it. That's 6 plus 1. Okay. When you do that, you should get 6 plus 1 times 25 over 100 should give you what? I think it will give you 1.7, right? 1.7. Yes. It should give you 1.75 rather. 1.75. 1.75. So let's see how to operate this 1.75. It means 1.75 position. That's the meaning. 1.75 position. But how do we get 1.75 position? You didn't say the second position so that I'll know that, oh, like 1 to the second position. You said 1.75 position. So to solve this kind of thing, we are going to count the first position 1. So you know that the next 7.5 will be between 43 and 61. It will be between them. So to do it rightly, you find the difference between 43 and 61. What's the difference between 43 and 61? The difference should be, I think, 18, right? So you use the difference, which is the 18, to multiply the remainder. The remainder, which is 0.75. 0.75. What I mean by this is that you've counted 1 out of 1.75th position. You've counted 1 out, which is 43. So to get a 0.75 position, you have to multiply the difference by 0.75. When you multiply it properly, you get 13.5. 13.5. 13.5. 13.5. So the result you get, you add it to the first position. You add this 13.5 to 43. When you add 13.5 to 43, you get 56.5, which is here. So when you follow same procedure for 50th percentile, you get 83. When you follow, in order not to waste time, kindly do that for me, okay? When you solve 75th percentile, you get 101.75. Using same procedure, okay. For the 50th percentile, you change this 25 to 50. For the 75th percentile, you change this 25 to 75 before you solve. So you follow same procedure. Okay. So let's go to the next question. Answer question 33 to 35 with the information below. It said the probability that a particular knee surgery is successful is 0.85. Full stop. If 3 knee surgeries are conducted, 33. What is the probability that all 3 knee surgeries are successful? We know that the probability that a knee surgery is successful is 0.85, isn't it? So this means that the first surgery is successful, 0.85. They said 3 knee surgeries, and okay, the second one too is successful, meaning all the 3 are successful. We are finding the probability that all the 3 hours are successful. So the first one is successful, and the second one is successful, and the third one too is successful. Okay, this is all about changing your English words to mathematical expression. That's the only thing. The probability that one is successful is 0.85. So they are asking you that what's the probability that all the 3 are successful? So the probability that the first one is successful and is multiplication, the second one is successful, and the third one is successful. So you multiply the 0.85 times 0.85 times 0.85, you get the answer to be B. That's 0.614. Okay. So let's proceed to the next question. The next question says, what is the probability that none of the 3 knee surgeries is successful? None is successful. Now, to be able to solve this properly, none is successful. You'll be wondering, what's the probability that one will not be successful? If the probability that one is successful is 0.85, then probability that one will not be successful should be 1 minus 0.85. Remember that principle. Okay, the probability of failure is equal to 1 minus probability of success. So probability that one is not successful should be 1 minus probability that one is successful, which is 0.15. 0.15, right? And question 34 is asking us that what's the probability that none of the 3 surgeries is successful? So if none of them is successful, it means that the first one is not successful, 0.15, and the second one too is not successful, 0.15 again, and the third one too is not successful, 0.15. 0.15. So we multiply 0.15 times 0.55 times 0.15, you should get 0.003375. 0.003375, sorry, and it's approximated to this. So the answer is C. Okay. Then the next question says, what is the probability that at least one knee surgery is successful? The probability that at least one is successful should give you 1 minus probability that none is successful. Probability that none is successful. Okay. Always remember that at least one is equal to 1 minus probability of none. And at least 2 is 1 minus probability of none plus probability of 1. I won't take you there for now. Just know that whenever a question says at least 1, just 1, no, not at least 2, just at least 1, it means 1 minus probability of none. So if probability of none is 0.003, then 1 minus 0.003 should give you what? 0.997. So the correct answer for question 35 is D. Let's go. Question 36 says, find the number of ways of forming 4-digit codes in which no digit is repeated. Question 36. Now, how many, when you take your phone, your keypad phone, how many digits are on it? Like, or when you want to form a code, okay, when you want to form a code, how many choice do you have to select to form a code? You see that when you want to set a code on your phone, it gives you 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So when you count them, there are how many? There are 10. Even though 10 as a number is not part, but counting them normal, like 1, 2, 3, 4, 5, 6, up to 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 in numbers. Okay. So to solve this one, you are going to say 10 permutation. It's a 4-digit code. Okay, it's 4. So we say 10 permutation 4. Okay. And 10 permutation 4, the formula for permutation is n factorial over n minus x factorial, which is 10 factorial divided by 10 minus 4 factorial. Don't confuse this with combination, okay? As for combination, you still multiply with 4 factorial at this place. You still multiply with 4 factorial. For permutation, you only stop here. 10 factorial divided by 10 minus 4 factorial. So you put this on your calculator, then you get an answer. But another way of doing that is, when you take your calculator, you can press the permutation straightforward. You just type 10, 10, 1, 0. Then to get a permutation, you press shift. Then you check where the multiplication sign is. Under the del, delete. Under the del, you see multiplication sign times over there. When you press shift before pressing that multiplication sign, to give you P in form of capital letter, that's permutation. Then you fix 4 over there, then you press equal to sign. You get the answer straightforward. Okay, you get the answer straightforward. So let's go. So the correct answer for question 37 is what? 10 permutation. What? Is it 37? Yeah, 36, sorry. So the correct answer is 10 permutation 4, which is 5040 ways. Okay. So let's proceed. The information below relates to the answer 37 to 40. So let's use it to answer 37 to 40. A box contains 6 red, 3 white, and 5 blue balls. A box contains what? 3 reds, 6 whites, and 5 blue balls. Now, if 3 balls are drawn at random, one after the other without replacement, find the probability that all are red without replacement. Okay, find the probability that all ours are red without replacement. Find the probability that all are red. To get a probability that all are red, it's very simple. First, you have to know the total number of balls. What's the total number of balls? The total number of balls is 6 plus 3 plus 5, which is what? 14. Okay. But the question is asking that if 3 balls, so hold this place constant, if 3 balls are drawn, 3 balls, okay, are drawn at random, one after the other without replacement, find the probability that all are red. To get the probability that all are red, it means that how many red balls do you have there? 6 red balls, isn't it? So 6 combination. They say all the 3 are red. So 6 combination what? 3. All 3 are red. Okay. 6 combination 3. Okay. Red. Total number of red balls. Combination 3. Since they are saying all the 3 are red. All are red. Okay. Divided by total number of balls, combination 3. So that's 14 combination 3. So you can fix this on your calculator by, let me take you back to the calculator. You can bring the division first, then you press 6. To get a combination, you press shift, then the division sign. You know, permutation is multiplication sign, so you come to the division sign for combination. So 6 combination, and you press 3. Then you come to the denominator and fix 14 combinations and 3 to there. Then you press equal to sign. Then you get your answer straightforward. Since it's MCQs, you don't have to waste time. So when you do that properly, you get 0.0549. Okay, 0.0549. So the correct answer for question 37 is A. Okay, 0.0549. So let's proceed to question 38. Question 38 says, find the probability that 2 are red and and okay, and be very careful, and okay, 2 are red and 1 is what? Is white. 2 are red and 1 is white. So to do that, how many reds do you have? Remember, 6, right? So 6 combination. Since they say 2 are red, you say 6 combination 2, and that's times, okay, 1 is white. Okay, how many whites do you have? You have 3 white balls. So we say 3 total number of white balls, 3 combination. They say 1, right? So 3 combination 1. Okay, all divided by the total, that's 14 combination. 14 combination what? 3. You are selecting 3 balls. Okay, make sure this and this are the same. 2 plus 1 is 3. Okay. So when you fix this on your calculator, just like how I show you how to fix the combination on your calculator, when you do that properly, you should get 0.1236. So the correct answer for question 38 is D. So let's proceed to question 39. Question 39 says, find the probability that at least 1 is red. At least 1 is red. At least 1 is what? Is red. Find the probability that at least 1 is red. This is very simple. Remember that I told you that to find the probability of at least 1, it should be 1 positive 1 minus probability that none is red. None is red. Okay, none is red. 1 minus probability that none is red. So that will give you 1 minus. So what will be the probability that none is red? Now, if none is red, how many non-reds do we have? None is red. How many non-red do we have? Like balls that are not red. There are 8. We have 8 non-reds. Because we have 14 balls in total. If 6 are red, then 8 are not red. So not red is 8. Okay, 8 combination. It said none are red, isn't it? Non-red. So none of the 3. So meaning these 3 are not red, divided by, meaning these 3 are not red, okay, divided by 14 combination, divided by 14 combination 3. So when you fix it to your calculator, this should be separate. 1 minus, then you separate this. 8 combination 3 divided by 14 combination 3. When you solve it properly, I hope you should be able to get the C as your answer, 0.8462. Okay, so that's the correct answer for question 39. So quickly, let's go to question 40. Let's go to question 40. Question 40 says, find the probability of getting one of each. Now, to get one of each, it means that you get 1 of red. There are 6 red, so 6 combination 1. And there are how many whites? We have 3 whites, isn't it? So 3 combination 1. They say 1 of each, okay, times how many blue do we have? The last one, we have I think 5, right? So 5 combination 1, all divided by what? 14 combination 3. As for 14 combination 3 is the denominator always. Okay, so when you solve this, when you fix it on your calculator, just like how I show you how to press a combination, when you do it properly, you should get 0.2473. 0.2473 as your answer. Okay, So when you see similar question, that's how to solve it. So let's go to question 41. Question 41 says, a cyclist recorded the number of miles per day that she cycled for 5 days. The recordings were as follows: 13, 10, 12, 10, 11. The mean number of miles she cycled per day is, to calculate the mean, you are going to add all of them and divide it by what? Let's say 1, 2, 3, 4, 5. So there are 5 numbers, so you divide it by 5. So let's see. 13 plus 1 is what? 23. Plus 12 is what? 35. Plus 10 is what? 45. And plus 11, that's 56. And 56 divided by 5 gives you what? 56 divided by 5 gives you, I think, 11 point something. Check it out. Okay, so the correct answer is D. Okay, the correct answer is D, 11.2. So let's proceed to question 42. Question 42 says, it is stated that more students are purchasing graphing calculators than any other type of calculator. Which measure is being used here? How do you know that students are purchasing graphing calculators than any other? We use the mode to detect. Okay, the mode is the most occurring value, the most occurring one. Okay, the most occurring variable. Okay, so we use the mode. Okay, more students, the more here tells you that you use it to detect the one that occurs the most, so it's the mode. Okay, so let's proceed to question 43, sorry. Question 43 says, which of the following is not a measure of central tendency? Which of the following is not a measure of central tendency? A, the mode. B, variability. C, median. And D, mean. This is the most simplest question among all. The measures of central tendencies are mode, median, and mean. Okay, the measures of central location. Okay. Then question 44. Given the following data set of data, that was 12, 32, 45, 14, 24, and 31. What is the total deviation from the mean of the data values? Please don't waste your time when you see this type of question. Whenever you see a question asking you for total deviation from the mean, the question didn't say mean deviation. No. The question didn't say standard deviation. No. The question didn't say variance. Oh. The question said total deviation from the mean. Whenever a question asks you of total deviation from the mean, the answer is always 0. So for this one, the answer is not in. The answer is not in the possible answers. So all the possible answers are wrong. So if let's say the examiner asks you to shade E, okay, if you think the answer is not there, you just shade E. But if there's no like instruction like that, you can raise up your hand and let them know that because you have problem with question 44. Okay, the invigilator will come closer to you and let them know that you have problem with question 44. You should be very confident that the total deviation from the mean is always 0. Okay, in one of the lecture video I did on YouTube, if you watch it, I prove why. I've proved it over there, so you can check it out. I have some other videos there, you can watch them. Okay, yeah. So the total deviation from the mean is what? 0. Okay, you don't have enough time. I would have proved it. I would have proved it right now, but let's proceed. So the answer is 0, and 0 is not an impossible answer, so they are all wrong. Okay, they are all wrong. So let's proceed to question 45. Question 45 says, which of the following is true for a negatively skewed distribution? Which of the following is true for a negatively skewed distribution? The answer is B. Okay, for a negative skew, the mean is less than the median. At the same time, the median is less than the mode. For what? Negative skew, the mean is less than the median. When we say skew, someone will ask, what does skewness mean? When something slants, when a curve slants, we say this, the curve is skewed. What I mean by that is that when you have a curve like this, and it's skewed, meaning it slants, Have you seen? So this curve slants to your right, so it's a right skewed curve. When you have a curve like this, it skews to the left, so it's a left skewed. Okay, another name for right skewed is positively skewed distribution, and another name for left skewed is negatively skewed. So in a positive skew, the mean is greater. The mean is greater than the median, and the median is greater than the mode. But in a negative skew, the one that skews to the left, the mean is less than the median and the median is less than the mode. So the correct answer for question 45 is B. The mean is lesser than all of them in a negatively skewed distribution. So if, let's say, the next question asks you for positively skewed, then for that one the mean is greater. So question C, for instance, is, let me see, be very careful, the median should be at the middle. So the mean is greater than the median and greater than the mode. So C is positively skewed and B is negatively skewed. So be very careful. So let's go to question 46. 46 says, a single numerical value used to describe a characteristic of a sample data set, such as the sample median, is referred to as the sample statistic. Okay, the correct answer for 46 is D, sample statistic. Okay, a single numerical data value. A single numerical value used to describe the characteristic of a sample data. The numerical value we use to describe the characteristics of a sample data is called statistic. No S at the end, sample statistic. And the one we use to describe the characteristics of a population is population parameter. Okay, we call it population parameter. But for this particular question, the answer is D, sample statistic. If the characteristic is referring to a population, it's called population parameter. If it's a sample, it's sample statistic. When you see some possible answers and they've removed the population, they've just written parameter, remember that I still go for the population. And this too, they've written statistic. Let's say they didn't write sample, they just write statistic without S. At times they would like to confuse you. They can write statistic and they can also write statistics. Don't choose the one ending with S. The one ending with S is the course you are reading, statistics. Okay, but the one without S is the characteristic of a sample. Okay, so question 47 says, which of the following is true for a positively skewed distribution? I've answered this question when I was answering question 45. Okay, positively skewed, meaning it slants to the right. Positively skewed, it slants to the right. So the mean should be greater than the median and should be greater than the mode. So be very careful with question C and D. Mean is greater for the two of them, but look at here, median is at the middle, here mode is at the middle. Don't choose D, the answer is C. Okay, the mean should be greater than the median is greater than the mode. Okay, so question 47 is C. So let's go to question 48. We are almost done. 48 says, which of the following would be affected the most if there is an extremely large value in a data set? Question 48, which of them will be affected the most? So the answer is D. The mean is affected by extremely large values. Okay, the mean is affected. The mean is affected. Okay. Question 49. Please, to know the answer for question 48, go and learn the characteristics of the mean, the properties of the mean, the properties of the median, and the properties of the mode. When you read them properly, you keep them, you know that it is the mean is affected. Okay, so let's look at question 49. 49 says, if the number of values in a data set is even, if it is even number, okay, and the numbers are ordered, then A, the median cannot be found. B, the median is the average of the two middle numbers. C, the median, mode, and mean are equal. And D, none of the above. The answer is B. If you remember, let's say 1, 2, 5, 9. You see that we have 1, 2, 3, 4. There are 4 in numbers. That's what they mean by the even over here. If I didn't mean that they were 5 in numbers, they are odd. So if you have something that if you have a data set that's even in number, to find the median of such data set, you are going to take the two middle numbers and add it together and divide it by 2. So these are the two middle numbers. I didn't mean that it was 5 in number. You would have gotten a middle number easily, one middle number easily, isn't it? Isn't it? Like 1, 2, 3, 4, 5. The middle number will be 3, so 3 is the median. But for this one, you have two numbers at the middle, so you add them together and divide it by 2. So that's what we mean by the average. The average of the two middle numbers. Okay. So the answer is B. So 50. Question 50 says, what type of distribution is described by the following information? What type of this? See, mean is 5.5, median is 5.3, and mode is 4.4. Don't forget this. Remember that when mean, look at this mean is greater than the median, is greater than median, and the median is greater than the mode. Whenever a mean is greater than the median and the median is greater than the mode, it is positively skewed. Don't forget. So the answer is D. But I didn't mean that the mean was lesser than the median and the median was lesser than the mode, then it's negatively skewed. But if the mean is greater, if the mean is bigger than the median and the median is greater than the mode, then it's positively skewed. Okay, don't forget that. Question 51. What type of distribution is described by the following information? Mean 56, median 58.1, and mode 63. Here, the mean is less than the median too is less than the mode, meaning the mode is greater than the median and greater than the mean. So this is negatively skewed. Since the mean is lesser than the median too is less than the mode, so it's negatively skewed. So the answer for this is A, is negatively skewed. Okay, since the mean is less than the median and the median is less than the mode, okay, it's negatively skewed. So let's go to the next. The next question says, use the information below to answer 52 to 56. A sample of 10 students was asked by their instructor to record the number of hours they spent studying for a given exam from the time the exam was announced in class. Now, the numbers of minutes spent in a computer lab by 20 students working on a project are given below. So this is a stem and leaf plot. It's supposed to be a line here. Stem and leaf. Now what this stem and leaf means is that if you want to put this stem and leaf in a raw data, but it means when you take this 30 and this 0, it means 300. When you take this 30 and this 2, it means 302. When you take 30 and 5, it means 305. 305 again. If you are putting them in raw data form, if you are writing them one after the other, so it means 300, 300, 302, 305, 305 again, 306, 306, 306, 308. When you come to the next one, 400, 402, 402, 405, 407, 409. That's the meaning. Then this means 500, 500, 501, 502, 505. Then the last one means 601. That's 601, and 603, 603. Okay, that's if you want to piece, like if you want to put them in raw data form, if it's not in a form of stem and leaf, so that's the meaning. Okay, so to get a median, this is a starting point, and this is a what? This is also the ending point. To get a median, we want to look for the middle number. So let's cancel out this. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8. So let's say this 8 will cancel out. 1, 2, 3, 4, 5, 6, 7, 8. It will cancel out all these 8. We want to look for the middle number, and this 02 will cancel out this 5. So the two middle numbers are 2, 2. That's 402 and another 402. That's the meaning. So to get a median, we have two numbers at the middle. So we say 402 plus, you add the two numbers at the middle, 402, another 402, divided by 2. When you do this, you still get 402. So the median is 402. So question 53 says the mode of the data set is. Now to get the mode, okay, so let's see, to get the mode, the mode means the most occurring number. So we have 6 here 3 times, and nothing like that occur anywhere again. So it means 306 is there 3 times. We have 306. Others are not occurring as much as that. So the mode is 306. Okay, the mode is 306. So let's proceed to the question 54. The question 54 says the mean for this data set is. Now to know the mean for the data set, you are going to add everything together and divide it by the total number. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4, 5, 6. That's 14, 22. 20. Yes, they are 22 in number. Or 20. 8 plus 6, that's 14 plus 4 plus this 4. Yeah, they are 20 in number. Okay, 20. So what this means is that to find a mean, you say 300 plus 302 plus 305 plus 305 plus 306 plus 306 again plus 306 plus 308 plus 400 plus 402 plus 402 plus 405 plus 407 plus 409 plus 500 plus 501 plus 503 plus 505 plus 601 plus 603, all divided by 20. When you do it, well, you should get your answer as, I think, C. That's 403.8. If that's not the answer, you can correct it. Okay, that's the procedure. So use your calculator to do that, please. So let's go to question 55. Question 55 is asking for the range. The range of this data set is. Now to know the range, let's go back to the stem and leaf. Range means that the highest value minus the lowest value. So what's the highest value? The highest value is 603 and the lowest value is 300. Okay, 300. The highest value is 603. Okay, so to calculate the range is the highest number, which is 603, minus the lowest number, which is what? 300. The lowest value, which is 300. So 603 minus 300 gives you what? 303. So the correct answer for question 55 is D. Okay, so let's proceed to question 56. It said given 20, 40, 50, 60, and 80, determine the mean deviation. Oh, we should determine the what? The mean deviation. Now, mean deviation, let me say MD, is equal to the sum of absolute value of the deviation, as x minus mean, absolute, okay, divided by how many values? And let's say divided by n. The formula is sigma x minus mean, the absolute value of x minus mean, divided by n. And to solve that, what that means is that, okay, let me create a table to make it look easy. Now, you create a box for x, each x value, okay. Then you find x minus the mean, x minus the mean, x minus the mean. X minus mean means deviation, okay, it means deviation. That's what we call the deviation. Now, write each x's under the column for x. 20, let's write them, 20, 40, and 50, 50, 50, 60, 60, and the last one is 80, 80. Now, before you can find a deviation, you need to know the mean. The mean will be 20 plus 40 plus 50 plus 60 plus 80, all divided by 5. So 20 plus 40 is for 60, plus 50 is 110, plus 60 is 170, plus 80, that's 250. So 250 divided by 5 gives you what? 50, right? So the mean is 50. So to get a deviation, 20 minus 50 is what? Negative what? 30, isn't it? Negative 30. 40 minus 50 is what? Negative 10. Negative 10. 50 minus 50 is what? 0. 60 minus 50 is 10. 80 minus 50 is what? Positive 30. Positive 30. Now you find the absolute. Absolute means that, sorry. To get the absolute value, the absolute of the deviation, as x minus the mean, absolute of any negative number should give you positive, okay? So 30, 10, then you still have your 0, you still have your 10 back, okay? The absolute, you just convert the negative numbers to positive, okay? That's the only thing. So 30, okay? So the formula says sigma x minus mean, and sigma, the addition of absolute value of x minus mean. So these are the absolute values of x minus the mean. So the sigma of it, the addition of all, that's the meaning. So when you add this, 30 plus 10, that's 40, plus 0, 40, plus 10, 50, plus 30, that's 80. So it gives you what? It gives you 80. The sigma x minus mean gives you what? 80. 80 divided by, what's the number of values? 5, right? So 80 divided by 5. So 80 divided by 5 gives you what? It gives you 16, right? So the correct answer for question 56 is C. Okay. There was a place I was asking that the total deviation from the mean is 0. This is the evidence to show that. I didn't mean that we had, like, if you don't get the absolute value of this, if you add all these deviations together, you definitely get 0. Negative 30 plus negative 40 is negative. Negative 30 plus negative 10 is negative 40, plus 0 plus 10 plus 30 to give you 0. That's the meaning of total deviation. But that's not our interest here right now. We are finding mean deviation, okay? But this is a proof. This part is a proof. This part is a proof for that. Let's go to question 57. 57 says, which of the following is not a discrete probability distribution? We have two probability distributions, the continuous probability distribution and the discrete probability distribution. Okay. Examples of discrete probability distributions are binomial distribution, Poisson distribution, multinomial distribution, and hypergeometric and geometric distribution. Yeah, they are examples of discrete probability distribution. And examples of continuous probability distribution are normal distribution and exponential and some others. Now, when you look at this, the odd one among this 57, the odd one is C. Because binomial, Poisson, and multinomial are all discrete probability distribution. So normal is odd among them. So normal is not a discrete probability distribution. Okay. So the correct answer for question 57 is C. 58. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen, and 2 women is to be chosen. Don't be very careful with this word, and 2 men is to be chosen. How many different possibilities are there? Now, to know the different possibilities that are there, how many women do we have? We have 7 women and we have 5 men, isn't it? So 7 women and we have what? 5 men. Now, a committee of 3 women and 2 men is to be chosen. So the number of ways in which you can choose that should be number of women, that's 7, combination You need 3 women in that committee, isn't it? So combination 3. Okay, and that's times. How many men do we have in general? We have 5 men. Combination, how many men do you need in a committee? You need 2. So when you do this, when you put this on your calculator, you get a number of ways in which that can be done. So 7 combination 3 times 5 combination 2. I show you how to where to get a combination on your calculator without wasting my time. Just go and click it there quickly, then we move. Okay, so 7 combination 3 times 5 combination 2 should give you, okay, actually 7 combination 3 is 35, isn't it? And 5 combination 2 is 10. 5 combination 2 is 10. So 35 times 10 is 350. So the answer is B. Okay, so let's proceed to question 59. Question 59 says, given that a sample is approximately bell-shaped with a mean of 25 and a standard deviation of 2, the approximate percentage of data values that are expected to fall between 19 and 31 is. You see, there's a way to solve this question. Okay, there's a way to solve this question, but I want to show you something. Now, there's a rule that when a mean plus one standard deviation, a mean plus or minus one standard deviation, the percentage between them is 98%. Okay, 68%, sorry, 68% will fall within the mean plus one standard deviation. You should keep that rule in mind. So 68% will fall within it. 68% of the total value will fall within that. Also, the mean plus or minus two standard deviations will have 95% of the values within them. 95%. Okay, we are going to use this rule that I'm stating here to solve this question. Also, the mean plus or minus three standard deviations will have approximately 99.7% of the values within them. 99.7%. 99.7%. Okay, so you'll be checking. The answer is between B, C, and D. Okay, so to do that, now look at the question. The question says the mean is what? 25. Okay, so let's see. The mean is 25. Let's operate a plus first. Now, but they are saying between 19 and 31, isn't it? Between 19 and 31, let's say 19, 31. What is the standard deviation? The standard deviation is 2, isn't it? Now, when you add 2 to 25, you get what? 27, isn't it? When you add 2 to it again, you get what? 29. When you add 2 to it again, you get what? 31. You see that you've moved 3 standard deviations. 1, 2, 3. Isn't it? Like 25 is the mean, isn't it? So 2. The standard deviation is 2. We said we want to check 3 standard deviations. How many standard deviations will you get from 25 to 31? That's the meaning. So when you add 2 to 25, you get 27. That's one standard deviation. When you add 2 to 27, you get 29. That's the second standard deviation. Then when you add 2 again, you get 31. That's the third standard deviation. Let's check it for 19 again. We said minus, right? Plus or minus. This was plus. This side was plus. And this side should be minus. So let's see. 25 minus 2 will give you what? 23, isn't it? 23 minus 2 will give you what? 21. And 21 minus 2 again will give you 19. So you see that there is minus 3 standard deviations and there's also plus 3 standard deviations. So the correct answer for this is D. So the correct answer for this is what? Is D. So there are 3 standard deviations. It is three standard deviation away from the mean. Okay, it's 3 standard deviation away from the mean. So the correct answer for that is D, 99.7%. So you must know this in your mind. Okay, you must know it. Then let's look at question 60. Question 60 says, let me clean this place so that you can see clearly. Question 60 says, for which of the following is the coefficient of variation the smallest? Now remember that the formula for coefficient of variation, we write it as CV, coefficient of variation. The formula for coefficient of variation says standard deviation over mean, x bar. Here they've written x. They wanted to write x bar. Okay, I think it was a typo. Okay, I've written x over here, so it's a typo. So x bar. Okay. Now the formula for this coefficient of variation is standard deviation divided by mean. So 2 divided by 10 is what? Is 0.2. Also, let's check this. 3 divided by 14 is, check it, use your calculator, 0.214. 0.214. Then 5 divided by 30 is what? 0.167. 167. Excuse me. 167. So 0.167. 0.167. Then the last one is 8 divided by 39 to give you 0.205. 0.205. So which of them is the smallest? 0.200. 0.2 is the same as 0.200. If you want to leave it in 3 decimal places, 200 is smaller than, is it the smallest? No. The smallest will be 0.167. So the answer is C. Okay. So the answer is 6. The answer is C. So that's the end of this. Please don't forget to subscribe to my YouTube channel so that when I post more questions, you can see them very early. Okay. Thank you for watching.